All right, I think my camera died, so in second period, so I'm gonna kind of finish through how we used our calculator to come up with the same things we found by hand. Okay, first thing is we're gonna y equals, and we're gonna type in the function that we're interested in. Now we have to use x's. It's just the way our calculator is programmed instead of t's. The next thing we're going to do is, if I were to graph that, most of your graphs, like I said, are going to be standard view. They go from -10 on the x-axis to +10, and the same thing on the y-axis, which doesn't render a very good parabola for us. So what we're going to do is we're going to go to our window, and this might be something where you got to jockey back and forth in regards to coming up with the correct window. And it might be something, we've done things by hand, so I'm going to use those values, but maybe I go, maybe I want to go from -1 to then maybe 8. But now I'm going to leave my x scale alone. That just means that these over here, every interval between 2 hash marks is represented in 1 unit. And now my y minimum, let's say my y minimum, I don't care about the negative y-axis because we're talking about this point here is where we hit the ground. We don't want to go underground. And we really don't care, I didn't talk about this, I don't think, in both classes, but we really don't care about the values over here that are negative, because remember, this is time, so we don't care about negative time. So that's why we really only focus on the first quadrant here. But let's say I make my y-max, and let's say I didn't do all the preliminary hand work. I make my y-axis 100, and I go a scale by tens, and I graph it. Maybe it's a little bit better looking than what we started with initially, but I'm still missing some stuff up here. So I'm going to go back to my window, and I'm going to mess around, and maybe I go, 180. Maybe I increase by 20s now. And I graph that, and again, I just missed the tip of that thing. So I'm getting closer to this thing. So you just got to mess around every once in a while to get what your curve looks like. Okay, I'm actually going to go one step further. I'm going to make the y minimum -40, and we're going to graph. Making the y minimum -40 is going to allow some room down here for my. You see how it says maximum x equals 2.5, that kind of stuff. My information that pops up here should not come over the x-axis now, which is going to be nice. But we can do some things here that we did by hand. One of the things we were interested in, when does this thing equal 160? Okay, well, I'm going to come down to y2. I'm going to type in 160. And it's going to put a horizontal line in here at 160. And I should be able now to use my calculator's functions to find out what that ordered pair is right there where they intersect. Okay, and let's actually do this so we got a better screen for you guys to see. So I'm going to go to second trace, which is going to take me to the calculate functions. I'm going to go down to 5, which is intersect. And I'm going to move my cursor. My cursor, you see, it's that weird cursor now with the open dot on it. But it's just going to tell me that I can move basically left and right on this curve. And I'm going to move that cursor close to where I think the intersection of the 160 and the parabola is. I'm going to hit enter. It's then going to jump me to the next line. I can move that left and right, or the next curve. Notice it tells me what curve the cursor is on. So I'm going to move close to where I think that intersection point is, hit enter. It's going to ask me to guess, which I just hit enter again. And it's going to search for all those ordered pairs in that region and find the two that match. And the two that match are 0.918 and 160. And if you match back to the work we did in class, 0.919 was what we found by hand. We rounded, and this is giving me that 0.919.
Yeah, it's round right now, dude.
Next period. So then, the next thing we want to do is we're going to go in and go second calc one more time. Go to 5, and we should be able to scroll now over to the other x-intercept, or intersection, I guess, not intercept. Hit enter. Puts me on the next curve. It's good enough for me. Hit enter. It's going to ask me to guess or search through this stuff, and it finds the other one. Okay. So now we got the 0.919 and 4.08, and in between there, we are above 160. The next thing we want to do is they ask for when this thing comes back to the ground. Well, it comes back to the ground, it's looking for this point right here where my cursor is, and that's an x-intercept. So I'm going to go to second calc. I'm going to look for an x-intercept. Now, it doesn't say x-intercept directly, but it says 0, which is a synonym for that. So I'm going to hit 0, hit enter. Then we'll come down here, and it says left bound. Left bound just means that they want you to, on your curve, select a point that is to the left of your intercept. Enter. Now it says right bound, so I'm going to go to the right of where I think my intercept is. So what we're using there is what we call the intermediate value theorem, and it understands that if you have a positive y value and a negative y value, you should be able to search between those and find a y value of 0. And that's what the calculator is going to do. When I hit enter again, finds the y value of 0 and the associated x value, which is our 0, which is the time that this thing comes back down to the ground, is 6.04 seconds. Okay. A lot of different things we can do with these things. Second calc, again, we can go to the maximum at 4. Right, second calc, maximum is 4. There we go. And now I go to the left bound, so saying find the value to the left of where you think your maximum is. I'm going to hit enter. Go to the right where I think my maximum is. Hit enter. So now my calculator is going to think about and look at all the x and y values through there. It's going to find the largest y value. And that largest y value then, when I hit enter again, is 200, which happened at a time of 2.5 seconds. Okay, so those numbers all mimic what we did in class by hand. Okay, might be a little bit more efficient than using the quadratic formula. Okay. My suggestion is to do the stuff by hand, and then on homework especially, use the calculator to verify those things, and if you have time on a test, definitely use the calculator to verify those things.